Coordinate geometry, drawing straight lines. Graphs of linear equations. A linear equation is an equation that can be written in the form ax plus by equals c, where a, b and c are numbers, and a and b cannot both be 0. Here are some examples. Now they may not initially be exactly in the form ax plus by equals c, but they could be rearranged. 3x plus 5y equals 30 is a line that crosses the y-axis at 6 and slopes downwards. 4y equals 3x plus 12 is a line that crosses the y-axis at 3, sloping upwards. Y equals 2x plus 5 is a steep slope that crosses the y-axis at 5. 3x equals 7 is a vertical line that crosses the x-axis at 2 1/3. Y equals 6 is a horizontal line that crosses the y-axis at 6. And 2x equals 5y is a line that passes through the origin. On the graph, we see that all of these are straight lines. A linear equation always has a straight line graph, and this makes them quite easy to draw accurately, since we can use a ruler. So let's see how we can draw a line from the equation. If we have a linear equation, there are several ways of drawing the line it represents. First of all, the equation may be in the form y equals a, there's no x term there, or x equals b, and there's no y term there. If the equation is of the form y equals a, then the graph is a horizontal line passing through a on the y-axis. If the equation is of the form x equals b, then the graph is a vertical line passing through b on the x-axis. Let's look at an example. On the graph, plot the graphs of y equals 7 and x equals minus 2. Well, to do this, in question 1, in this case, whatever the value of x, y always has the value 7. So all the points lie on the horizontal line with a height 7. So the graph is a horizontal line crossing the y-axis at 7. In question 2, the equation is x equals minus 2. Now that means whatever the value of y, x is always equal to minus 2. So the graph is a vertical line crossing the x-axis at minus 2. Now let's suppose the equation is of the form y equals mx plus c. So for example, y equals a half x plus 3. Now to solve this, if x is equal to 0, then y is equal to 3. So the graph crosses the y-axis at the value 3. Also, if x increases by 1, then y increases by a half. So the graph has a gradient of a half. So to draw the graph, we draw a triangle at y equals 3 with base 2 and height 1. We then draw the line up the hypotenuse of the triangle. And that gives us the graph. So we have, if the equation is of the form y equals mx plus c, then the graph passes through c on the y-axis and has gradient m. We can use this to sketch the graph. Probably the most common method of drawing graphs is plotting points. Now we can choose values of x and work out the corresponding values of y. We often put these in a table, and then we can plot 2 or 3 points and join with a straight line. 2 points is all that's needed, but the third point acts as a check. If the 3 points don't lie in a line, then we've made a mistake somewhere. So let's look at an example. Suppose we draw the line of 2y equals 3x minus 5. To solve this, we need a table. We choose some values of x, and for each of these, evaluate y. So let's draw a table with 2 rows and 4 columns. The first column is just for the labels x and y. We then choose numbers to go in the x row. Let's say -1, 1 and 5. And then we calculate the values of y. So, in the first column, if x is equal to -1, then we have from the equation 2y equals 3 times -1 minus 5, or 2y equals -3 minus 5, which means 2y is equal to -8, or y is equal to -4, and we put that in the table. Now if x is equal to 1, then 2y is equal to 3 times 1 minus 5, or 2y equals 3 minus 5. So 2y is equal to -2, and y is equal to -1. And we put that in the table. If x is equal to 5, then 2y equals 15 minus 5. So 2y is equal to 10, and y is equal to 5. And we put that in the table. We can then plot these on a graph and join with a straight line. And we see they do lie in a straight line, so it's unlikely we've made a mistake. Another way of drawing the graph is what's known as the cover-up method. This is quite quick, but does not always work. So if we have an equation of the form 3x plus 2y equals 12, then we can use this method. We can plot 2 particular points, and we choose when x is 0 and when y is 0. So if x is 0, we can cover up the x term. Now that leaves us with 2y equals 12 or y equals 6. If y is 0, then we can cover up the y term. And that leaves us with 3x equals 12, and so x equals 4. So that means we plot the points 0, 6 and 4, 0. We then join those up with a straight line, and that's our graph. Linear graphs. The following is an exercise to draw graphs of linear equations. Pause the video at this point and have a go at them yourself. When you're ready, start the video again and I'll go through the answers. Okay, let's see how they're done. In the first question, we have to make a copy of the graph grid and sketch the graph of the following equations. Well, the first one, x equals 3, is a vertical line crossing the x-axis at 3. All points on the line have an x-coordinate of 3. And part 2, y equals -2, is a horizontal line crossing the y-axis at -2. All points on the line have a y-coordinate of -2. In the third equation, we have y equals x plus 3. Now this crosses the y-axis at 3 and has gradient 1. So we draw a triangle starting at the point 3 on the y-axis, and we go 1 across, 1 up. And then we draw the line up the hypotenuse of this triangle. In part 4 we have the equation y equals 2x. Well, in this case the constant term is 0, so it crosses the y-axis at 0. In other words, it passes through the origin. It has gradient 2, so we draw a triangle with width 1 and height 2, and then we draw the line up the hypotenuse of the triangle. And that's the graph of y equals 2x. And for part 5 we have y equals -x. Again, this passes through the origin, and this time it's got a gradient of -1, so we draw a triangle of height 1 and base 1, but going downhill. And then the graph is drawn along the hypotenuse of the triangle. Now we do the same in question 2. It says make a copy of the graph grid and sketch the graph of the following equations. And the first one is y equals 1/3 x. Well, when x is 0, y is 0, so it passes through the origin and it has a gradient of 1/3. So if we draw a triangle with base 3 and height 1, then the line will be the hypotenuse of the triangle. In question 2, the equation is y equals 1/4 x plus 2, so it crosses the y-axis at 2 and has a gradient of 1/4 or 1/4. So at 2 we draw a triangle with height 1 and base 4, and then the graph is along the hypotenuse of the triangle. In question 3 we have y equals -1/2 x plus 5. So the graph crosses the y-axis at 5. It also has a gradient of -1/2. So we draw it sloping down. The triangle has a height of 1 and a base of 2. And then we draw the line along the hypotenuse. In question 4, the equation is y equals -x minus 1. So that crosses the y-axis at -1 and has a gradient of -1. So we need to draw a triangle sloping down with height 1 and base 1, and then we can draw the line going down the hypotenuse of the triangle. And in part 5, we have y equals -3x plus 4. So that's a graph that crosses the y-axis at 4 and has a gradient of -3. So we need to draw a triangle sloping down with height 3 and base 1. And then the graph lies along the hypotenuse of the triangle. In question 3, for each equation, make a table, and on a copy of the graph grid, plot the following graphs. Now the first one is y equals 3x minus 1. To do this, we need to draw out a table. In the first column, we put the labels x and y, and then we choose values of x. So we could choose 0, 2 and 3. From that we work out the values of y. Now the equation is y equals 3x minus 1. So if x is 0, y is equal to 0 minus 1, which is minus 1. If x equals 2, then y is 3 times 2 minus 1, which is 6 minus 1 or 5. If x is 3, then y is 3 times 3 minus 1, which is 9 minus 1 or 8. So we can plot the points 0 minus 1, 2, 5 and 3, 8, and then draw the graph by drawing a straight line through the points. For the second equation, y equals 7 minus x, we need a table. We fill in the first column with just the labels x and y, and then we choose values of x. Let's choose 0, 3, 6, for example. Then we work out the values of y. So if y is equal to 7 minus x, if x is 0, y equals 7 minus 0, or 7. If x is 3, y is equal to 7 minus 3, which is 4. And if x is 6, y is equal to 7 minus 6, which is equal to 1. We can then plot these points on the graph, that's 0, 7, 3, 4 and 6, 1, and then join with a straight line going through the 3 points. Finally, we're asked to find the point where the graphs intersect. Well, looking at the graph, we see that they intersect at the point 2, 5. For question 4, we're asked, for each equation, make a table, and on a copy of the graph grid, plot the following graphs. And they are y equals 4 minus 2x and y equals 4x minus 5. And then we're asked to find the point where the graphs intersect. Now we have y equals 4 minus 2x. So we draw out a table, and the first column is labelled xy. We then choose values of x, let's say 0, 2 and 4, and we work out the values of y. So, if x is equal to 0, y is equal to 4 minus 2 times 0, which is 4. If x is equal to 2, then y is equal to 4 minus 2 times 2, which is 4 minus 4, or 0. If x is equal to 4, then y equals 4 minus 2 times 4, which is 4 minus 8, or minus 4. We can then plot those points, that is, 0, 4, 2, 0, and 4 minus 4, and join them up with a straight line. And that's our graph. For the second equation, y equals 4x minus 5, we need a table. And the first column is x and y, and then we choose values of x, let's say 1, 2 and 3. We then use those values to work out the values of y. So in the equation y equals 4x minus 5, if we substitute x equals 1, then y is 4 times 1 minus 5, or 4 minus 5, which is minus 1. If x is 2, we have y is equal to 4 times 2 minus 5, which is equal to 8 minus 5, or 3. If x is equal to 3, then y is equal to 4 times 3 minus 5, which is 12 minus 5, or 7. So we plot the points 1 minus 1, 2, 3, and 3, 7, and then join with a straight line, and that's our graph for the second equation. Now we're asked, where do the graphs intersect, or where do they cross over? And in the diagram we can see this is at the point 1.5, 1, or we can write that 1.5, 1. In question 5, we're asked to use the cover-up method to draw each of the following graphs on a copy of the following grid. And we have 3x plus 4y equals 24, 2x plus 5y equals 10, 5x plus 6y equals 30, and 4x minus 3y equals 12. Now to solve this, let's look at the first one, 3x plus 4y equals 24. Now we can cover up the x term, and what we're left with is 4y equals 24. In other words, y is 6. We can then cover up the y term, and that gives us 3x equals 24, or x equals 8. So, on the grid we can plot the points 0, 6 and 8, 0, and then we just join them up with a line, and that's the graph. In question 2, we've got 2x plus 5y equals 10. If we cover up the x term, that gives us 5y equals 10, or y equals 2. If we cover up the y term, we get 2x equals 10, or x equals 5. So we can plot the points 0, 2 and 5, 0. And then if we join up with a straight line, that gives us the graph of the equation. In part 3, we have 5x plus 6y equals 30. If we cover up the x term, that leaves us with 6y equals 30. In other words, y equals 5. And if we cover up the y term, we're left with 5x equals 30, or x equals 6. So we can plot the points 0, 5 and 6, 0, and then we can join with a straight line to get the graph. In question 4, we have 4x minus 3y equals 12. If we cover up the x term, we have minus 3y equals 12, which means y is equal to minus 4. If we cover up the y term, we have 4x equals 12. In other words, x is equal to 3. So if we plot the points 0 minus 4 and 3 noughts, we can join with a straight line, and that is our graph.